Let me make some more specific points about the model projection problems. Okay, so here is the observed Indian monsoon rainfall for each month, January, February, March, and so on. So, for example, here August has the highest rain, and here July, August, October, November. So these are regions with the northeast monsoon, not the summer monsoon. Here it is high in November, and so on and so forth. And if you look at various models that are used for projections of climate and reconstruction of past climate from industrial revolution to now, these models are also used to do past climate like the Little Ice Age or last glacial maximum, and so on and so forth. So the biases affect pretty much everything we do, but you have to be keenly aware of what the biases are and how to account for them. That's the main point. Okay. The point I want to make here is that if you look at the comparison of models with observed rainfall, you see that none of them is really realistic. Okay. So sometimes reds are in the right place, but not the other things. Yellow is not in the right place at all. The purples are not, and so on and so forth. So if you look at the Indian monsoon rainfall, if you look at the average over the whole country, then most models will do reasonable cycle where the monsoon starts in about June, first week of June, it peaks in July, August, dies off in September. But if you look at the spatial distribution, then they don't do so well. This is just a reality we have to deal with, right? These are all the famous models being used in the business, like Geophysical Fluid Dynamics Lab of NOAA in Princeton, HADGEM2 in the UK, CSIRO, the Australian model, CESM, the US model, and so on and so forth. Okay, so now look at the projections. We don't know how accurate the projections are because we don't have data for the future, but you can compare the models and see that they are all somewhat different, with lots of them showing yellow here. So this is not so simple to interpret because the observations, as I showed in the monsoon podcast, say that monsoon has decreased over the last 5 to 6 decades by about 10%. Okay, but the models did not capture that trend very well, maybe because they missed the impact of pollution on solar dimming and less warming of the land than expected. But the models warm the land more than the ocean just based on heat capacity, and they increase the monsoon with global warming. And that's pretty much what's happening here. August rainfall is increasing in most models. Is this reliable? There is some other ways to diagnose this in terms of the dynamics, and it is argued in a couple of papers that the monsoon projections in the models are not reliable. They are not dynamically consistent. Okay, this is a problem of rainfall, especially when you go to regional scales. Nonetheless, we can look at projections of Arctic sea ice. This is for various scenarios for the outer decades 2081 to 2100 for RCP 2.6, 6.0, 4.5, and 8.5. And you can see in 8.5 it completely disappears. Gone. Arctic ice is gone, right? At the rate at which it is melting, it's very likely that if we keep up the current emission rates, it will disappear much before 2081. Okay, here is the time evolution of various scenarios, the number of models and the number of scenarios used, and here is the historical period before 2005 or so, and it had been decreasing as we saw. And the future projections are not very bright. If we use RCP 4.5 with various options or RCP 2.6 with various options, maybe we will save some of the sea ice, as you can see here. This is not bad, right? Whereas 4.5 is also not bad. 8.5 is really, really bad. Are these reliable? Well, The question then becomes, do we want to worry about how accurate the models are, or we want to worry about the trend where we are already in, and that there seems to be no hope of returning to recovering Arctic ice if we continue greenhouse gas emissions. So it's a question of how do you take decisions and what the decisions even would be, right? Does everybody reduce their emissions? How do you tell the economically developing countries that they should reduce their emissions? Because all the emissions historically can be attributed to rich industrialized countries. This is not an easy task, but nonetheless, under negotiations in UFCC, they are discussed. Various divisions are made for countries, and countries are given options on what actions they can take and they should take. We will talk a little bit about that later on. Okay, so complicated issue. Decision making is not easy. So climate change is a natural science problem, but all the decisions are going to be socio-economic and social science problems. So all the uncertainties have to be dealt with in that sense. So climate change in that sense is called a wicked problem. I will talk about that maybe later on, which means this terminology wicked problem came from a couple of urban planning faculty from Berkeley in the 1960s, where they said these problems do not have a solution. They can only be resolved. And the examples they give are like education, crime, and let's say healthcare. Nobody agrees on how to do that. So you make an agreement which lasts for a while, then you have to redo the agreements and make some changes. So climate change is similar. The solutions are not so obvious. Like ozone hole was solved because you replaced CFCs with HFCs. But how do you deal with climate change? Who does the action? How much? How do they grow? And so on and so forth. So very difficult problem. It's called a wicked problem, which basically means they have no solutions. They don't even have a good definition of the problem itself. So they can only be resolved, which means they have to be resolved again and again. Okay?